Okay, here's our introduction to multiplying and simplifying rational expressions. When you say the word rational expression in math, you want to think fraction because rational expressions, I guess they include more than that, but typically this is what we're thinking about is fractions. So we want to learn how to multiply fractions. Just as a quick little review, well, maybe before, here's some examples of rational expressions. So expression, something with a variable in it. Rational, there's a fraction. I guess they don't have to have a variable in it, like this one. I'd consider that a rational expression, as I would all of these other ones. So in this section, what we're wanting to do is simplify these and also multiply them. Okay. When we're looking at any rational expression, remember that this dividing line means divide. So I could write it like 5 divided by 6, or I could write it like 5 divided by 6. They mean the same thing. Similarly over here, when you have a binomial on the top of a fraction, typically if you rewrite it like this, you do put it in brackets. Because if you wrote it like x minus 3 divides 7, then in terms of order of operations, you'd want to do this first, then that. But that's not what this says or what that says. So don't write it like that. Put brackets around. Okay, I guess the first thing when we are dealing with fractions and variables, the first thing I identify is that there's some numbers that we can't have on the bottom of a fraction. So anytime that I divide by 0, like if I have 10 divided by 0, try that on your calculator and you'll find that you get an error. Or it says undefined. And often in math we'll just write a 0 with a line like it through it like that, indicating that it's undefined. So if I have an expression like this one or like that one, if there's a value that I put in for x that makes the whole bottom 0, then that expression, and if it's an equation, I can't use that number as a solution, or I can't use it as a variable to plug in there. For example, in this first one, 65 over x, if I put a 0 at the bottom, if x is equal to 0, I'll just write that. If x is equal to 0, the expression is undefined. Similarly here, what would I have to put in there to make the whole bottom thing 0? If I put a 0 in, 0 take away 2 is negative 2, that's allowed. I can have negative or positive numbers on the bottom. I just can't have 0. So what number would I plug in for x to make that bottom 0? Hopefully you're thinking 2, and that's correct. In this case here, this expression is defined for every value that I throw in for x, except x cannot be equal to a positive 2. If it is, it's undefined. Here's a couple to try. So for what values of this expression is it defined? When I look at p, p's alone on the bottom, so I would say for this one, p cannot be equal to 0. Let me skip that one and go to this one. Notice this one doesn't have a p on the bottom. In other words, all values of x are okay. They're defined, the expression is defined for every value of x. But here I have some x's on the bottom, but this one's a little bit more difficult because there's a couple x's. I do notice though that this is the form x, x, and a number, x squared x and a number. So maybe like I did in the last section, I could factor that bottom. So if I factor the bottom, I think it's x minus 3, x minus 2. Notice that all I did there was I factored the bottom. And now I have two factors. In this case here, if I were to put in a positive 3 there, I'd get 3 minus 3 is 0. 0 times anything is 0. Therefore, a positive 3, not good on the bottom here. So I would say x cannot be equal to positive 3. What else can it not be equal to? hopefully you're saying also x cannot be equal to a positive 2. So this expression is fine as long as you don't put a 3 or a 2 in for x. For those two values, the expression's undefined. Okay, now that we've got that sort of out of the way, let's start looking at multiplying. So when you're multiplying expressions, rational expressions, it's the same as multiplying fractions. If you have a half times by 3/5, what you do is you multiply the top, multiply the bottom. Whoops, I'm getting my answer before it's time. 1 times 3 is 3, 2 times 5 is 10. So that would be the answer to that question. And I just multiplied the numerators, multiplied the denominators. So I can do that. Same thing here. A over b times x over y. I can multiply the a, the x, multiply the b and the y. Also notice, because this is multiply, I could maybe rearrange that. I could call it a over y times x over b. Since it's multiplying, I can move those factors around. Well, the a and the x on the top I can move, the b and the y on the bottom I can move. I can't move the b from here up to the top, but the two numerators I could swap. And that's called the commutative law. All right, so in this case here, if I'm multiplying this, I could take the 2x minus 1 and multiply it by x over the 5x minus 12 multiplied by x. And in this particular case, it's a little silly for me to do that. I guess I'm just showing the rule because typically what we're going to do when we simplify these is we're going to look for common factors like this. So we probably wouldn't multiply both of those by x. But maybe in some cases I might have to do that to help me simplify an expression. Let's try some more. Here, this is a good example. To simplify an expression, maybe using something like this is what I'll have to do. So I've got this over this times this over this. So I could rewrite it as x plus 3 times a negative 1 all over x minus 6 times a negative 1. Do you notice just the slight difference there? In this case here, I have two fractions multiplying. Over here, I've got one fraction where I have a product on the top and on the bottom. I could keep going with this one and multiply the negative 1 in if I wanted to. I might as well. Negative x minus 3 all over negative x plus 6. So there would be the product of that particular one. Although you could leave it like that. Okay, so when we're looking to simplify a rational expression, I want to use that same concept that I was doing here, that I could multiply both top and bottom by something, but also maybe if I rewrote an expression to have the something the same on the top and bottom, that I could cancel those. Here's an example. If I have 2x minus 6 over 4, I could simplify that by factoring the top. So the top, I can factor a 2 out. It would leave me with x minus 3. And then on the bottom, instead of 4, I know 4 is 2 times 2. So I can write this as 2 times 2. Hopefully you can see where I'm going here. So notice I have a product on the top, product on the bottom, but two of those factors are the same. So I'm going to rewrite those as one fraction times, and then what I'm left over with. Do you notice just the slight difference between the two there? But now 2 divided by 2 is equal to 1 times x minus 3 over 2. And when you multiply anything by 1, it doesn't change it. It's just x minus 3 over 2. So this would be the simplification of that first expression. Let's try another one. This is a little bit different. On the top, I have an x squared x in a number. I've already factored that in this video. I think it's x minus 3 times x minus 2 all over x minus 3. And lo and behold, I have a factor on the bottom and the top that are the same. So I could rewrite this as x minus 3 over x minus 3 times x minus 2. Notice there's nothing underneath that because I didn't have anything else there. I guess I could put a 1 if I wanted to. Now this here, x minus 3 over x minus 3, is the same thing as 1. Times, I have x minus 2 over there, and 1 times x minus 2, of course, will be just plain x minus 2. That would be my simplification of that original expression. Okay, here's a couple others. Why don't you try these and see how you do, and then so press pause and then press play again. See how you do. Okay, with this first one, oh, I don't need an equals. I can see that what divides evenly into those? Probably 4. 8 maybe goes into both of those. So I could factor an 8 out. That would leave me with 2x plus 3. And then on the bottom, I could re-express 32 as a product of 8 times 4. Notice I'm looking for things that are the same. So I would have 8 over 8 times 2x plus 3 over 4. Notice just a slight change there. I just took that factor of 1 out and put it by itself. So that's the same as 1 times 2x plus 3 over 4. And when you multiply anything by 1, it doesn't change it. So it's 2x plus 3 all over 4. That would be my simplification of that one. Now, one of the things that you might do is you might simplify and you might get rid of some steps. Like this step here, you might say, well, I can sort of see that it's right there anyway, so why don't I just cancel those out and go right to the answer? If you want to do that, that's fine. Just be careful when you cancel an 8 and an 8 out here, that this sign here, or this operation, is multiply. If that's positive, I couldn't do that. Okay, so you could maybe get rid of these couple steps here and go right from here to there. That's fine. But if you need to put those other steps in, if that helps you, go for it. Ooh, more practice with factoring. So x squared minus 1, that's a difference of squares. X minus 1, x plus 1. 2x squared plus x minus 1, that's an x squared x and a number with a 2 out front. I could use the AC method, but I think on this one I'm going to guess. So it's 2x and an x. This is 1, so this has to be 1 and a 1. And I'm thinking this one's minus and this one's plus. Let me just confirm. 2x squared, yeah, plus 2x minus x. And that's going to give me a positive x. Oh, that's good. Negative 1 times positive 1, negative 1. So yeah, that's correct. Now I look for factors that are the same. Notice I can't cancel this x with this x. Or back here, I can't cancel any of these x squareds with each other. I first must factor. But now I see the x plus 1s are the same. So if I'm following like what I did above there, I could write as a x plus 1 over x plus 1 times x minus 1 over 2x minus 1. These are identical, so that's a factor of 1 that can be eliminated. So my answer to the question is x minus 1 over 2x minus 1. I'm dying at this point, because this one's similar to this one here, I'm dying to cancel those, but they're not identical. If this would have been a 2 up here, I could have canceled them. But at this point, I can't. Okay, a couple more questions. Oh, and this is just a thing to be careful with canceling, like I was saying. Canceling this x with this x, that's not allowed. No, you can't do that. So just be careful with your canceling. Similarly, if you see that 16 goes into 32 twice, so 1 and 2 there, you could do that only if you're also dividing the 16 into that. If you're not, you can't do that. No, stop, don't do it, don't be tricked. Now, one thing when we're looking at some expressions where they look very similar, like x minus 5 over 5 minus x, one of the things we can do with these is we can factor something out of either the top or the bottom to make these the same. I'm going to take the bottom and I'm going to factor out a -1. If I factor out a -1, this becomes a -5 and this becomes a plus x. If I were to rewrite that, the top stays the same. The bottom, I still have a -1 there. Just if I rewrite these in the proper order, it'd be x minus 5. Notice on the bottom and top now I have the same thing. And so, if you want, you can put a bracket around those. You could cancel this one, and you'd be left with, there's no number written out front, but we can assume it's a 1. I'd be left with 1 divided by a -1. And 1 divided by a -1 is a -1. So I can simplify these as long as they're identical like this, the same sign, and these things just swapped. All I do is I factor out a -1 out of one of them, and then see if I can simplify. Try this one. Okay, I'm going to factor a -1 out of the top, so that leaves me with an x plus 5, and that's what I have on the bottom, x plus 5. This one and this one cancel, leaving me with just x minus 1. Okay, one last slide. And this is one where you might have to do a little bit more work, but it's the same kind of thing. Always factor, factor, factor. So x squared minus 9, that's a difference of squares, over 5 times, I see a 5 here, so automatically with this 10, I'm calling it as 5 times 2, over x plus 3. Now I see things that are the same. So I see a 5 here, and this is a multiply, so I can cancel that one and that one. I also see an x plus 3 on the top and the bottom, so I can cancel that one with that whole one. Notice I'm not just canceling an x, it's that whole term or the whole factor that's down there. So I'm left with on the top an x minus 3, and I'm also left with a 2. I could put times 2 at the back, but typically they write that at the first. And there's nothing on the bottom. I could write it over 1, but typically I would just leave it like that. Okay, hopefully that gives you some practice simplifying and multiplying rational expressions. Try some questions in the book.